Alright, so today we're going to talk about children's dosages. There's three types of children's dosages we'll talk about today: Clark's rule, Young's rule, and the body surface area method. First up, we have Clark's rule. Clark's rule says if you take the weight of the child in pounds, multiply that by the adult dose, and then divide by 150, you'll get the child's dose. Important to note that the child's dose will be in the same units as the adult dose. Alright, so let's assume we have a 75-pound child and the adult dose is 325 milligrams. Let's see, 75 pounds and 325 milligrams. Alright, so let's set it up. Remember, you multiply the weight of the child in pounds times the adult dose, in this case 325 milligrams. So 75 divided by 325, and you're going to divide all of that by 150. Alright, 75 times 325 divided by 150 is 162.5 milligrams. So that's utilizing Clark's rule to determine the child's dose when the adult dose is 325 milligrams. Young's rule. So Young's rule says that if we take the child's age in years, multiply it by the adult dose, and then divide that number by whatever the child's age is plus 12, it'll give us the child's dose. Now, Young's rule is not as accurate as Clark's rule, although it's still accepted with some medications. As you might imagine, there's larger and smaller children, and for the most part, medication is best dosed based on weight. However, there are certain age restrictions that would sort of prohibit the use of a higher dose in a child at a younger age. Alright, let's say you have a 6-year-old. Okay. And they're receiving a dose based on an adult dose of 400 milligrams. Alright, so what we're going to have to do is you're going to take the child's age in years, 6, multiply that by the adult dose, 400 milligrams. You're going to divide all that by the child's age in years, 6, plus 12. You can remember the 12 because it's like the cutoff between a child and an adult for the purposes of medication. Alright, so we're going to have 2400 divide 18, and that's going to give you a repeating decimal. We'll just round it a bit, 133.3 milligrams. And remember that the adult dose is always going to have the same units as the child's dose. So because we're using this as a factor in the equation, so this is how you can use Young's rule to calculate a child's dose. And now we're going to talk about the last method to determine a child's dose, the body surface area method. This one's very straightforward. Once you have the body surface area, you can simply divide that by 173 and multiply by the adult dose. So the tricky part here, similar to the other two, is just remembering the factor that you're either dividing by or adding. So again, we're just going to take the given child body surface area, divide that by 173, and then multiply that by the adult dose, and that'll give us the child's dose. So, quite simply, if you're told the body surface area is, let's say, 7.3 meters squared, that's the units for body surface area, and you're going to take that and divide that by 173, and then multiply that by the adult dose. So in this case, adult dose we could say is 250 milligrams. I'll go ahead and say that 7.3 meters squared is a very, very small body surface area. Perhaps it's a very, very young child or a premature child, something along those lines. So let's see. All right, so 7.3 divide 173 times 250 is 10.4. And again, just like the other two dosages, this is going to be in milligrams. So this is how you're going to calculate a child's dose using the body surface area method.